Hello dear students, this is your Jagan sir. Welcome back to our YouTube channel Physics with Jagan sir. I hope all of you are enjoying my classes and I hope all of you are fine. And next, first point is we have successfully completed dimension analysis, and after that we had seen kinematics complete chapter of kinematics in 13 classes, and that is very sufficient and very important classes because, as I told you again and again, not only concepts, we are also discussing most important logical critical numericals, which will help, definitely helps you to crack your final examination. Now today onwards we are going to start new chapter, Newton's laws of motion. In Newton's laws of motion, first point is what is what are the different types of forces are present. Forces are of two types. Number one, contact forces. Contact forces. Contact forces means, I will give you an example. Suppose here a block is present which is tied with a thread, then there will be a tension will develop. Tension is the amount of force present in the thread, rope, thread or rope, right? That tension is pulling the block towards the rightward direction with an acceleration A. That means over the block there is a force F which is equals to tension, and there is a contact between the block and the thread. So this is the example for contact forces, right? Number two is non-contact forces. Non-contact forces. Non-contact forces means, best example is gravitational force, because Earth is always trying to pull any object of having mass towards its center with the acceleration of minus g. So what is the force value here? It is mg. So this is the force acting on every object having mass on the Earth, right? So Earth is pulling the object even if it is at a height h. There is no need to have contact between the object and the surface of the Earth. Object and the surface of the Earth, right? This is what is This is what is non-contact forces. Non-contact forces, right? Then next one is Newton's first law of motion. See here, suppose case 1. Case 1, here an object is at rest position. An object is at rest position. Right? Now, until and unless I am applying some amount of external force or energy or momentum, whatever that may be, until and unless I am applying these physical quantities on this object, the object will maintain rest position. Will maintain rest position. That means it does not get any acceleration. It does not get any acceleration, right? So this is the Newton's first law. He says that until and unless application of the external agencies, the object remains maintain its original status. Original status. So you can understand the case two. You can understand the case two. Here, suppose a car or object is moving, which is moving with a uniform velocity, and there is no external agency like energy, force, momentum, whatever that might be. It is not acting on this. It remains in the uniform motion only, uniform velocity only, right? This is what is the Newton's first law. Newton's first law. Now, second point is, see here, as I told you, here mass m, an object is present, right? For this object, some external agency like energy, force, momentum, like energy, force is acting on the object. As these are acting on the object, this object will attain certain amount of velocity. Certain amount of velocity. The velocity attained by the mass m, right? The property of giving certain amount of velocity to the object having mass m is known as momentum. Momentum is equal to mass into velocity, where momentum is vector quantity, momentum, and velocity is also vector quantity, and p is equals to mv. This is the case, momentum case. This is what is linear momentum. Linear momentum, right? Now see here, Newton's laws of second motion. Sorry, Newton's second law of motion. Newton's second law of motion. That means, see very carefully here, an object is present, an object is present. This object is originally having certain amount of velocity and mass m. And Newton's law says that force is equal to change in momentum by time, change in time. That means, let us assume here it is having velocity v1 and here it is having velocity v2. That means its velocity is changing with respect to time. Its velocity is changing means if the object is getting acceleration. The object is getting acceleration, right? Either it is positive acceleration or negative acceleration, that is a different case, but its velocity is changing. Its velocity is changing from one location to other location during some time interval of dt, during some time interval of tt, right? Now this force is equal to d by dt of mass into velocity, mass into velocity, momentum is equal to mass into velocity. And see here, actually here I need to write mass into right, okay, velocity. But note one point here, here is the two possibilities are existing. Number one possibility is there is a change, there is a possibility of change in the mass. The second possibility is change in the velocity. Now we can write it is dm by dt of v or m dv by dt by using uv formula of the differentiation, that is d by dx of uv. We can write u dv by dx plus v du by dx. By using this formula, right, we can write like this, we can write like this, right? Now the next part is, if mass is, or if velocity is constant, then differentiation of a constant with respect to time is equals to 0. Then force is equals to v of dm by dt. This is actually called as thrust. And about this concept, we are going to see in our later classes, right? Later classes. Now let us assume the second case, if m is equals to constant. That is, like we are considering the car is moving with the velocity v1, after having certain time, it is turned its velocity into v2. That means here the velocity is changing but the mass remains constant. In such a case, the equation becomes f is equals to d by dt is equals to mass into velocity, right? That is, mass is constant. Now f is equals to mass into acceleration. F is equals to mass into acceleration, and this is what is Newton's second law. Newton's second law, right? I hope I am very clear from my side, and I gave you the required amount of concept for understanding what is Newton's law, what is Newton's first law, what is Newton's second law, and how we can relate Newton's first law with the Newton's second law. This is what, through linear momentum. This is what we have covered now, right? Now let us go for the next concept. Sorry, next concept, impulse. What is impulse? Impulse is, and before we are going to see impulse, we know that force is equal to dp by dt, that is change in momentum by per unit time, change in momentum per unit time, right? Now this change in momentum is equal to force into dt, force into dt, right? Now this change in momentum is known as, that is pf minus pi is known as impulse. Impulse. So impulse is equals to force into dt, or impulse is equals to change in momentum. Change in momentum. This is what we call as impulse. And based on this concept, let us go through some numericals. And these numericals are the very basic, very conceptual, very little bit critical, and a little bit logical also. These are logical, critical, basic, and conceptual numericals. And try to solve these numericals without aid from my class notes after having, or after your understanding my class. Then you can go back to your worksheets after having understanding and after having a grip on my class, you can go through your worksheets that will give you enormous amount of knowledge. Right? Right. Now, the question is, in a particular crash test, a car of mass m is equals to 1500 kg, m is equals to 1500 kg, collides with a wall as shown in the figure. The initial and final velocities of the car are, initial velocity is equal to minus 15 meter per second and final velocity is equal to 5 meter per second respectively. If the collision lasts for time is 0.150 seconds. Find the impulse caused by the collision and the average force exerted on the car. Now they are asking us what is the impulse, and just now we have seen that impulse is equal to change in momentum, that is Pf minus Pi. So can I solve now? Impulse is equal to m Vf minus Vi, right? M is equals to 1500, Vf is equals to 5 minus of Vi is equals to minus 15. So 1500 into 20, which is equals to 30,000. This is what is impulse. This is what is impulse. And force exerted. Force is equal to change in momentum by time, that is impulse by time, and impulse value is here 30,000 and given time is 0.150 seconds. 0.150 seconds. This is equal to 30,000 into 10 to the power of 3 by 150. Actually here 150 into 10 to the power of minus 3, that if we comes on numerical, this will be 10 to the power of 3, 0, 0, 15, 2. So this is equals to 2 into 10 to the power of 5 Newton. This is what is the force exerted on the car due to what? Right? This is what is our first question. Let us go for the second question. In the second question, see, a body of mass m is equals to 1 kg falls from a height h is equals to 20 meters. From height 20 meters, the body is falling from the ground level, right? What is the magnitude of the total change in momentum of the body before it strikes the ground? Let us assume u is equal to 0, v before strike, change in momentum is how much? Pf minus Pi. And Pf is equal to mvf minus mvi, and vi means initial velocity, which is equal to 0. So m into vf minus 0, which is mvf. Right? And here vf is equals to by using vf square ui square 2a yes, right? Then vf square 0 2 minus g minus 20 400, vf is equals to under root of 400, right? Under root of 400. Then delta p is equals to mass is 1, vf is 400. So delta p is equals to under root of 400 kg meter no per second. This is the momentum, change in momentum, what they are asking before collision. This is the change in momentum before collision, right? Then what is the corresponding average force experienced by it? Now, force experienced. Now we know that force is equal to change in momentum by time, and here the time value we can find by using Sy is equals to u by t plus half a by t square minus 20 0 t plus minus 10 t square. So 5, 4, t is equals to 2 seconds. T is equals to 2 seconds, right? Then force exerted is F is equals to delta P by delta T, and the delta P value we got as root 400 by 2, which is equals to under root of 400 by 400. F is equals to 10 Newton. This is the force exerted. And see, this is the conceptual question and critical question also. And logically, you can think that this question is containing not only concept of Newton's laws of motion, this question contains the concept of kinematics also. Kinematics concept also inherited into the question. So you have to be very strong in understanding the concept of the kinematics to apply here at appropriate places. This is one of the most important understanding in the physics, right? Then see here, the third question is here an iron ball of mass m is equals to 50 grams, falls from a height 5 meters 5 meters and rises up to 3.2 meters. After falling here, it rises 3.2 meters after colliding with the horizontal surface. If the time of contact of the glass half is delta t is equals to 0.02 seconds, find the average contact force exerted on the ball by the horizontal force. Now, what is the force value exerted on the ball by the glass? See here, it will attain our initial velocity as when it is falling here. Initially it is 0, obviously. So vi is equals to, we can find vi value by using, again kinematics is dominating in our Newton's laws of motion chapter. So you have to understand how to relate kinematics with the Newton's laws of motion chapter also. Not only conceptual understanding, here numericals will help you how to relate these two things, right? Now by using v square u square 2a, yes. Now vi square is equals to 0 square 2 minus j, h value is minus 5. So which is equals to 2 into minus 10 minus 5 100 vi under root of is equals to 10. So its value is 10 meter per second. 10 meter per second. And did you notice one point here? The after collision, the object is rises to 3.2 meters and they said rises up to this point. So at this point, Vf is equals to 0. Vf is equals to 0. Right? Now, of course, it is moving with certain amount of velocity Vi dash. Then only it can rises up to the point, up to this point P, and it can stop there. How can I find that Vi value? Again, by using Vf square, Vi dash square 2 minus j plus h, because the object is moving in the upward direction. So this will be plus the h. Right? Then Vf is 0, Vi dash is equals to, which we are going to find, 2 into minus 10, h is 3.2. So can I find now Vi dash square is equals to 64 minus get cancel, then Vi dash is equals to 8 meter per second. That means after collision, the object attains a velocity of 8 meter per second. Right? Now, here initial velocity is, for our concept of change in momentum by change in time, m Vf minus Vi by time, and mass is 50 grams. 5 into 10 to the power of minus 3 grams, right? And Vf is 8, and 8 is moving in the upward direction, so I am keeping it as positive. minus of Vi. Vi is moving in the downward direction. See, Vi is moving in the downward direction. That's why I am keeping it as negative 10 by time given as 0.02 seconds. 0.02 seconds. Right? Which is equals to 50 into 10 to the power of minus 3 into 18 by 2 into 10 to the power of minus 2, which is equals to 5 into 18 by 2, 9, which is equals to 45 newtons. This is the amount of force exerted on the ball by the glass surface. Right? Again and again, I am saying physics is not a subject to memorize the concepts and apply and substitute the given values in the formulas. This is not at all a subject of physics. Physics is such a subject where you require the knowledge of previous chapters also. Because of the knowledge of previous chapters only, you can build the subject in the upcoming classes, right? Upcoming chapters. This is one of the most important to understand. And let us see the next question. See, a disk of mass 10 grams is kept floating horizontally through a 10 marbles per second. See here, 10 marbles per second are for hitting like this. So n is equal to 10 marbles, number of marbles per second. Against it from below, if the mass of each marble is 5 kg, mass of each marble is 5 grams, that is 5 into 10 to the power of minus 3 kg, right? Calculate the velocity with which the marbles are striking the disc. Assume that the marbles strike the disc normally and rebounds downward with the same speed. That means the marbles colliding can make my system to be at rest horizontally, right? And can you understand? Mg is the force acting due to earth on the disk, right? Now we can say F is equal to change in momentum by time. Now here m into Vf minus Vi is equal to time. And do you understand one point here? Initial velocity is not given, and the velocity with which they are hitting is given as. Calculate the velocity with which the marbles are striking the disc. Okay, right? Now, n number of balls are present. N number of balls are present. Then n by t. This is n by t into mass into velocity, and this one is 0, and this is equals to f, and f value is mg, and number of marbles striking per second is equals to 10, and mass of each marble is equals to 5 into 10 to the power of minus 3, and velocity which I am going to find, right? Then mass of the disk is equals to 10 into 10 to the power of minus 3, g is 10, 5 into 10 to the power of minus 3, Vf. Right. Then this one get cancelled, this one get cancelled, 2. So velocity is 2 meter per second. Right? Yes, completed. I hope you understand my concept and the application part also very clearly. And for your daily practice sheets and weekend examination papers, you better to follow my Telegram channel, Physics with Jagan sir. Have a great day. Take care. Bye bye.